Let's jump into the corrosion issues. Corrosion is very strongly connected with the ash-related issues. But we can distinguish between two types of corrosion. First is high temperature corrosion, and the second is the low temperature corrosion associated with acid dew point. But in fact, we focus on now mainly on high temperature corrosion because it exists inside the furnace, inside the boiler. Well, we found plenty of the mechanisms of the high temperature corrosion associated with the chlorine existing. It is associated with the gaseous chlorine, with the gaseous alkali chlorides, even in the molten alkali chlorides, sulphates, and carbonates. Of course, I don't want to explain every processes because they are quite complicated. I just want to show the examples and the main idea, the main simplified explanation. What is the role of the chlorine on the corrosion in the boiler? So let me explain it. What is the as I said, this simplified this is the simplified mechanism. What is the role of chlorine in the corrosiveness as a corrosiveness agent? Let's consider the surface of stainless steel used, for example, for heat exchangers in the boiler. Usually, if we consider, let's say, the normally oxidative atmosphere containing oxygen, water vapor, carbon dioxide. So, as you know, the stainless steel contain some, let's say, protective alloy, like a chromium and another one. So they create the protective oxide layer. Containing, for example, chromium oxide. So it protects against further oxidation, further corrosion. But if chlorine appear in the system, they create very cracked oxide layer. They destroy this compact and protective layer. So this is the, let's say, the main mechanism of the chlorine enhanced corrosion. Why we focus on a chlorine? Because paddy straw contains, in fact, a very big value of the chlorine. So this is why, in our opinion, it would be the main problem of the paddy straw combustion and co-combustion. But let's go more deeply to the corrosion mechanism. I just want to show only one. In fact, the most common, the most popular, if I want to say like that, it is active oxidation in the presence of the gaseous chlorine. The chlorine can be in the boiler atmosphere, can be in the different phases. One of the possible way is the gaseous chlorine. Of course, the first step is the release of chlorine compounds from the combustion of the biomass, even from the coal. But in biomass, the chlorine content is much more higher. So this is the first step. The second step is the transportation of the chlorine by the scale, by the oxide layer. So the chlorine penetrate this oxide layer and create some cracking, very porous cracked scale, and react with the metal alloy. Well, but the next step is the chlorination of metals, iron, chromium. The metal react with the chlorine and create the chlorine metal. But it is not end of the story, because this chlorine can be transformed again into the gaseous phase, and it can be transformed outward from the inner oxide layer to the outer oxide layer, so that again cracked more and more oxide layer create a very loose layer, and after that we just lose the protection against the further attack. But the next step can be again oxidation and create of the chlorine gaseous again. So this process surround, they can be let's say do it like a circle. So this chlorine effect is very dangerous, is very, let's say, destroy the oxide layer, protective oxide layer that is created on the stainless steel. So the consequence is, of course, we lose the protection against the corrosiveness. But the more serious consequence is unplanned shutdown of the boiler. It can happen if we have not control of the corrosiveness in the boiler system. But the question is, what the presence of the straw, of the biomass straw, of the straw biomass in the boiler, what is influence of this present on the corrosion rate? You can see this this chart on the here is a corrosion rate, but let me underscore that this is logarithmic scale. So if we consider only co-firing of the 10% of straw, the corrosion rate at the 20% is much more faster, because it is a logarithmic scale. If we consider the just straw burning, this corrosion rate would be even much more higher. Well, the question is, it is any possible way to protect against such problems, such issues? Of course, we can show some remedies against both ash-related issues and corrosion, but the remedies can be divided into very simple two groups. The first can be realized in the boiler, and the second can be realized in out of boiler. Also, even we consider the some, let's say, the combustion factors we can influence on the ash-related issues. For example, if we consider the fuel, the fuel contents, we have to know that more ash, more sodium, more potassium, and more chlorine means higher probability of slugging, fouling, and agglomeration. You already know that the main mechanism is the creation of the sticky and adhesive layers on the ash surfaces. But even we concern only the process parameters, we have to know, especially for the fluidization, if we decrease the temperature, we in fact avoid the agglomeration. Also, if we increase the fluidization velocity and decrease the residence time, we also avoid, we also have some protection against the agglomeration. The very important issue is the type and shape of the bed particles. If we have the bigger ones, the agglomeration probability is even higher. And also the last one process parameter is the, let's say, oxygen concentration in flue gas. What does it mean? If we have more reducing zones in the boiler, reducing, that's mean that it is less oxygen. So these zones, let's say, create a more serious problems of the agglomeration. So, as I said, the remedies can be divided into two groups. First is realized out of the boiler, the second realized in the boiler. So we already know that if we want to avoid the agglomeration, we increase the fluidization velocity, decrease the bed temperature. We have to exchange the bed more frequently, or even we can apply the more some alternative bed. If we apply some additives, we can obtain the remedy against slugging, fouling, and agglomeration both. Also, we can use the integrated methods. That's mean the precisely control of the process parameters and application of additives. But also, as we mentioned, we can use the out of the boiler remedies. For example, chlorine and potassium can be removed by torrefaction. Also, we can ask our farmers if it is possible. We can ask to reduce the fertilizers rich in chlorine, sodium, and potassium. Also, a very simple process is the leaching by water and or acid. So let me give you some examples in the next slides. But now we are focused on the additives, because additives are one of the more popular remedies against ash-related issues. In fact, application of additive during this process, it is not necessary to change the boiler system. Maybe a little more to prepare some transportation, to how to control, how to add some additives against ash-related issues. But these additives can be divided into two groups. First is additives influencing on the reactions in the gaseous phase. As you already know, sodium, potassium, chlorine, and sulfuric compounds. And the second is influencing on the physical and chemical of post-created deposits. The most popular additives are the kaolin and the halazite. They are most universal. That means that they work against slugging, fouling, and agglomeration. Also, we can find another in the literature. That means the calcium compounds, zeolites, and sulfur compounds. But sulfur are mainly against the slugging and fouling. Let me say something more about the halazite and kaolin, because, as I said, they are the most popular additives in the against ash-related issues. Kaolin contains mainly kaolinite, is the mineral clay, and if we add it into the boiler, the first step is we remove of course the water vapor, and kaolin is transformed into the metakaolinite. It is amorphous alumina silicate. This let's say chemical compound is very reactive against the sodium potassium. More similar is a halazite that also creates some very reactive phase against the alkali metals. We would like to underscore that in Poland we have the biggest in the world open cast mine of the halloysite. Even the kaolin is more popular. We have the biggest open cast mine located in Dunino in Poland. Is southwest part, close to Jelenia Góra. But the question is, we apply the additives. How does it work? What is the effect of the additives addition on the ash transformation, especially chlorine and sodium and potassium? So let's consider again the biomass combustion. As you already know, during the combustion we create some alkali metals, aerosols, very thin droplets of the aerosols, and if such a moment, if we add the kaolin or halloysite, we can obtain the reaction between these compounds. The mechanism is quite complicated, but the most important for engineers is what is the final product. The final product is a calcite or leucite. That melting temperature is even more than 1500 degrees of Celsius. So that's it is even higher than the high temperature zone of the pulverized boiler. So in fact, we create a very stable material that can be easier removed from the boiler. But what happened if we add the sulfur compounds? So the mechanism is quite different, because in fact we stabilize the HCl inside the furnace. HCl cannot react with the another components that can create some deposits, but HCl is removed from the furnace into the precipitation part. However, of course, we have to protect even every surfaces just out of the boiler, because even we have the higher content of the chlorine, we for sure obtain the higher content of HCl, so we have to protect such a surfaces. And this slide, as I mentioned in the beginning of the presentation, it touched the reality in terms of the boiler performance, because according to the Swedish scientists, they try to estimate what is the cost of the if we apply the different ways of the different remedies against ash related issues, is the kaolin, sulfur, ammonium sulfate, and the blast surface slag, against agglomeration and against deposits. So that means slugging and falling. So you can see that kaolin, also I want to say that halloysite are more universal. They works against both agglomeration and slugging and falling. The sulfur, they don't observe effect on the agglomeration. No effect is observed. However, as you can see, the price differences between the kaolin and sulfur application is large. It's even 10 times more comparing the kaolin and sulfur. Of course, this number was taken from the literature, so the different numbers would be for sure for Poland, for India, for another applications. However, this is only example that in some cases we can obtain in some cases maybe less attractive effect, but the price is lower. Another possible way to avoid some corrosion is application of a coatings of heat exchanger surfaces. But in such case, we have to consider the modernization of the boiler. For example, in the end of the year, every time when the boiler is, let's say, renovated, when the engineers check the everything inside, it can be done. We are in touch with our colleagues from the Silesia University of Technology, Faculty of Material Science. They have quite good experience, long-term experience in the coating. What is the message from this slide? You can see this column is a comparison of the corrosion when we don't use the coating, and here on the last column is the hot corrosion, let's say, rate if we use the coatings. Whatever method we apply, the flame, the plasma, or high or low velocity oxy, we can obtain the different results. So as you can see, in some cases the improvement is very high, is from milligram per centimeter square, means that the mass of the scale by the surface. So you can see the improvement. But in some cases, for example, here, the improvement is, let's say, insignificant. So you have to consider very carefully which type of the technology you can apply. And another examples from the literature out of the boiler remedies, especially for rice straw, because we found quite good results. That one scientific group tried to check what is the effect of leaching biomass. It was very simple: exposition of the biomass from the October to March. They even check what was the rainfall in millimeters, and after that they check what is the effect on the agglomeration. So during combustion of the, let's say, the treated biomass, they can combust this material stable without any effect of agglomeration. However, it is only one important point. We will say about that in the next webinar. Of course, the leaching by water is possible, is very simple way. But if we add the water into the biomass and put it without any control on the surface, without, for example, protection, we increase significantly self-ignition. We can in fact increase the probability of the fire. So pay attention. This leaching by water is a possible way, but you have to consider the possible control of the biomass stream. For example, put it to control what is the temperature inside this biomass stream.